So, good day, class. Welcome once again to another session of differential equation. Now we are already on the case number 3 of our linear differential equation in order n. So, this is our last case, which is auxiliary equation with imaginary roots. So, the first one is distinct roots, so meaning the roots are different from other roots. Then next is repeated roots, which is there are roots that are the same and repeated many times. Now, what if your root is imaginary? So example here, so you imagine, so example here, if you have uh, this one, so you have x squared is equals to negative 4. Therefore, your x, which is your root, will have an imaginary. So, you always remember that in imaginary, so kung nakay negative within your square root, meaning imaginary na siya. Ang imong negative 1 or that negative represent I squared. Okay? Kanang negative sa sud sa square root, it represent I squared. Okay? So obviously, when you get the I only, just square root it. So from here, for example, you have negative 4 sa imuhang na kuhaan ni mo root. So therefore, you have repeated roots. Sorry, you have imaginary roots. So, di ba, it's either positive or negative man ang square root, no? Ang result. So, since this is negative, move out the negative and retain the positive one. So, it is just the same that you have a negative 1 multiplied by 4. That's why it becomes negative 4. So, since negative 1 is just equal to I squared, which is the imaginary, you can just replace the negative 1 with I squared. After that, you will get the root x equals plus minus 2, then I squared, square root of that, it becomes I. Okay. So, now, on case number 3, so, sa case number 1, unsaon man nato pag-identify that the given equation is distinct roots. Diba? You will use this one, but you will, the b squared minus 4ac should be greater than 0. In that case, you will say that the given equation is distinct roots. If the equation is b squared minus 4ac, if that is equal to 0, then that is repeated roots. In case number 3, if you have an equation contains a, b, and c, then uh, and if the value or the result of that is less than 0, so in this case, the auxiliary equation has two complex roots. So here this means that is imaginary. Okay. So it has two roots. Okay. The first root is alpha plus imaginary times beta. The second root is alpha minus imaginary times beta. So positive, negative. Okay. Where alpha and beta are real roots and I squared is equal to negative 1 katong imaginary nato. So these real numbers are alpha. So in order to get the value of your alpha and beta, this is the formula to be used. Okay? So here, so mura siya og formula sa imuhang completing square para sa case number 2 sa to ang root. So in this case, that is the value of alpha. And your beta will be 4ac minus b squared, or the square root of 4ac minus b squared over 2a. So that's how you get your beta, and this is how you get your alpha. Okay. So why is it important to get the alpha and beta? Because in our general solution, this is the values that you will be substituting. Okay. So these two complex root then give a rise to two linearly independent solution. So solutions with e raised to the power of the first root and e raised to the power of second root multiplied by x. So in this case, it will be just equal to e raised to the power of alpha x, and this one will be equal to the cosine beta x plus I times sine x, and the negative sign also for the root 2. So this This way, we would talk about theorem number 5. So, here, this is sa case number 3, theorem 5 is very applicable. So, this is how you get your general solution. So, if the root 1 is equal to alpha plus the I beta or imaginary, so and R2 is alpha minus I beta, imaginary, or two complex root to the auxiliary equation na kining linear equation nimo a r squared plus b r plus c. So normal equation, no, special equation of the line. So then your general solution will have this form. So pag niagi ang general solution niya kay ano, no, kung sa distinct roots your arbitrary constant, then a raised to the power of root times x, di ba? Tapos kung repeated roots, ang sunod buta times na nato og x, di ba? Mamanto. But here in imaginary, since it is imaginary, you will have your alpha and beta. So and you will automatically have two arbitrary constants since in this imaginary you will always have two roots. Okay. So your y will be equal to e raised to the power of alpha x times c sub 1 cosine beta x plus c sub 2 sine beta x. Sorry. Let's try the first example. Okay. So let's check whether this equation is really the imaginary, auxiliary imaginary niya equation or the roots having an imaginary value. So checking, you'll just use the one I've given you above. So you have b squared minus 4ac less than 0. Should be less than in order to satisfy the condition of imaginary roots. So your b, this is a, b, and c. So your b is negative 4. So because the equation is always positive, so therefore the negative will always be carried by the constant variable. Sorry. So from here you have b, which is negative 4 squared minus 4. Ang a nato ani, since wala kay value ani, it is understood that is equal to 1. So 1. And your c is 5. So you have positive 16, you have 20, negative 20, so minus 4, negative 4. Is negative 4 less than 0? The answer is yes. Since it is less than, therefore, we could say that the given equation is imaginary roots or having an imaginary roots. Okay, so from here, you could get the auxiliary equation. Diba? Pareha sa case number 2, you could get the auxiliary equation. So, when you get the auxiliary equation so that makakuha ka roots, di ba? Pwede naman ni magamiton. So, the same process, kung ano mong y, na f of m na ikuhaon, then i-root nimo. Okay. So, from here, or actually, you may not do this one anymore. The most important part is your alpha and the beta. Okay. So, since alpha is equivalent to negative b over 2a, and your beta is square root of 4ac minus b squared over 2a, then we can just substitute the values of your a, b, and c from the given equation, like what we do here. So, since our a is negative, uh-huh, if our a is 1 and our b is negative 4. Since our b is negative 4 and our a is 1, so negative 4 times negative, that is positive 4, divided by 2. So, you have positive 2. So, here, your a is 1, your b is 5, di ba? Ang ang c nato is 5 from here. So, from there, so just substitute 5 and 4, we know that that is negative 4. So simply apply mathematics, yung negative 4 squared, that is 16. 5 times 4, that is 20. 20 minus 16, that is 4. Square root of 4, that is 2. 2 divided by 2 is 1. Then, in theorem number 5, as we've talked we've discussed how to get the general solution. In the general solution, since you already have alpha and beta, you just simply substitute your alpha because the equation general solution for imaginary roots is y is equals to e raised to the power of alpha x times c sub 1 uh, cosine beta x, no? Tawa. Cosine beta x plus c sub 2 sine beta x. So, since our beta is 1 and our alpha is 2, so you'll have a general solution of y is equals to e raised to the power of 2x times c sub 1 cosine x plus c sub 2 sine x since our beta is 1. Okay? So, this is our, so cosine x lang, sine x, and 2x. So, this is our general solution. Okay. Sir, what if the given is not fully A, B, and C? What if there is a part that is missing? Okay, so the same. Okay. So, from here, if someone is missing, then you substitute it with 0. Meaning, wala siya. 0 ang value. 0 times that is 0. That's the reason why wala siya. So, since this is second order, di ba? This is it's like we represent the y prime or second order as squared. So, this is our A, right? And we don't have y double prime is our A. We don't have y prime here. So, like what we have in the first example. So, we don't have y prime. So, y prime represents our B. So, our B, we assumed our B as 0. And we have our C since it is not derived. This is our C. So, you just get the auxiliary equation. So, if you could see, you get the auxiliary equation. So, from here, then actually case number 3 is very simple. It is very important now to get the alpha and beta. When you know your alpha and beta, then you could get direct to general solution. Here I'm just telling you that you how will you get your auxiliary equation if in case needed. Okay. So auxiliary equation, the same process sa case number 2. Then you have this one. So money siya. So then you will get the roots. Okay. Then you could get the roots here, that the roots will be imaginary. That you will know that the roots are imaginary. Okay. So how will you get your equation? So from here, check again. Again, if the given equation is imaginary, if it's really imaginary, so our A is 1, obviously. We don't have value here, so it is 1 since it is squared. Our A is 1. Our B is 0 since we don't have y prime ani or dy over dx. So that is 0. And our A is, in our C is 9. So you have 4 times 9, that is 36. This is 0. Negative 36 is less than 0. The answer is yes. So therefore, since this is less than 0, then this applies, or we could apply case number 3, which is imaginary roots. So from here, since we know that our alpha is 0 and beta is 3, alpha is 0, beta here is 3. So e raised to the power, e raised to the power of 0 is 1. So ma-1 siya 1 times this one. So c sub 1 cosine 3x plus c sub 2 sine 3x. So that's the answer. So now, how will you apply the given example to this initial value problem? So initial value problem and initial value and boundary value problems are problems with kini points. Okay? Na siya points. Murara pod kung if first order first degree differential equation mura siya to get the particular solution nimo. Okay, na siya boundary, meaning if you have enclosed part, na siya until asa anira kataman kini siya, anira siya mo end, ani siya mo start, so na kay boundary. Okay, so from here, to determine the unique solution to a first order linear differential equation, it was sufficient to specify the value of the solution at a single point. Okay, wait a minute ha. Okay,